My name is Aryush, and I'm here to present my solution on predicting the interaction profile of a person. So, the data set was given to us, but that was the trained data set as well as the test data set. So, in the trained data set, we can see that there were a total of around 9 columns and 30,732 rows. We had to predict the interaction profile of a person based on the other parameters like time in isolation, comfort, speaking, social recovery time, and many other things. So first of all, we imported the libraries like NumPy, Pandas, Matplotlib, and Seaborn. We created a data frame out of it by using the query.read CSV. This is the test. This is the data from the trained data set, as you all can see. After that, we did the analysis of the null values in the data frame, and we saw that there were many null values in the system, and along with 19 null values in the interaction profile itself. So what we did was that we removed all the null values with the help of several methods. Like we also did an analysis of the various parameters like comfort, public speaking, know how many people are there, yes, how many people are there. After that, so here you can see that since in comfort public speaking, which is a categorical column, there should be only two values, either yes or no. But there were some numerical values as well, like 2, 55, 5, and 54. So what we did is that we converted all these numerical values to NaN values. And what we'll do further, we will tell you. And also in this comfort public speaking column only, some of these no were written with small letters. We converted all the no with small letters to capital letter no. Now what we did was that we filled all the comfort public speaking NaN values with the string missing. Okay, so we converted it with missing, and you can see that we drew various plots out of it. After that, what we did is that in the numerical columns, we filled the NaN values with the mean value. Okay, here is another bar plot. Also, for categorical column, we filled it with missing. And finally, you can see, okay. So let's sum here. You will see that all the null values have been removed. Now, once we did that, we saw that in the DF social network count, there was some values which were string. But since this is in numerical column, we converted the string values to the numerical values with the help of pd.toNumeric. And after that, we filled the null values with the mean of the column. Okay. Finally, when all the NaN values were removed, what we saw was that in the interaction profile column, the yes and no were heavily imbalanced. You can see that here the expressive column people are 10,000, and for reflective people, it's just close to 3,800. So we can see that the data set is heavily imbalanced. And for heavily imbalanced data sets, what we do, we use mode analysis for oversampling. So here you can see that we imported and we applied smart analysis, and we found out the explain we sampled. After that, we first of all thought about applying logistic regression because it's the most basic algorithm for classification. The accuracy which we got was around 0.96 or 96%, but we saw that we can further improve the accuracy. So we went to uh, yes, we went to random forest. For random forest, we first of all predicted the accuracy, so it increased to 0.9701, which is an increment in as compared to the logistic regression part. But we saw that we can further optimize it by using hyperparameter tuning. So what we did, we used Optuna, which is a library based on Bayesian optimization for hyperparameter tuning, and you can see that we have done the Optuna by hyperparameter tuning here by using the objective function. We did it, and we got the accuracy to be around 0.9711, which was the maximum accuracy in our case. After that, what we did is we used the model to predict the result for the test.csv. Here you can see this X is basically test.csv. We have used df1 for loading the test dataset here. You can see that we have loaded the test dataset here. Okay. So we have loaded a test dataset here. After that, we have tried all the operations on the same test data set to remove all the null values. And after that, we took the X by dropping ID since it doesn't contribute much to the accuracy of the model. Now, we use the model to calculate the output for the test data set, and we can see that we are getting a good accuracy of around 0.9711. So, you can see that we are predicting with the help of the same model and by using the parameters of the hyperparameter tuning, and we got the accuracy of around 0.9708 for the test data set. You can see, and this is our maximum accuracy. Or we also used XGBoost for classification, but the results were not very good. Means they were at par with the random forest classification only. Also, we used hyperparameter tuning in this case also by using the Optuna package, but we didn't receive better results. We received the same amount of results. We can see that the accuracy has decreased in this case 0.969. So what we could do, we have to use random forest. We also use neural networks in our case. We also tried in our case neural networks with the help of PyTorch. But we can see that in this case also, but we again used hyperparameter tuning, and the maximum accuracy came to be around 0.96 only. So we went with random forest as a final model for the answer, and we did hyperparameter tuning of it, and we got the result. See. Here is the result. We got the result here, final here, and after that we converted it to CSV file. So final DF dot to CSV submission dot CSV. And this was a submission. So we submitted it. Thank you for your time.
Hello judges, this is my Kaggle Olympiad submission. My name is Sandeep Kumar Behr. Uh, this is where I predict the interaction profile. I will explain every step of my notebook clearly. See, I am first imported my necessary library like pandas, numpy, and after that I load the dataset, train, test, and metadata, and simple submission file. Then after I I am printing the first two row of each row, which help me to understand the structure and type of. So this is the output, and after that I create copies to keep original files untouched, then detect numeric and the category columns automatically. This help me apply different pre-processing step, each step consistency. And after I'll print the numeric columns and category columns. Here is the output. After that, from Sklearn, I import label encoder. For categorical feature, I use label encoder. I feed each encoder on the combined train and test value. This ensures the mapping and consistency at interface time and prevent unseen level mapping error when the predicting on the set. Then after that, I import simple imputer. After that, I drop an arrow without targeting to avoid trending or incomplete level. For missing value, I impute numerics with the median and categorical with most quickest value. So here is median is the robust to outlier and more mode for category gives common value and consistent. For that, I import a stand scalar. I scale numeric feature using stand scalar. Although random forest do not strictly require scaling, I standardize to keep pipeline consistent for future model for logistic regression to avoid a issue combining feature with different ranges. And then after that, I import train test split. Here I split data into 80% training and 20% validation using Stratify Using the Stratify uh, to preserve class distribution across set, stratification avoids Q value result to imbalance class. After I import random forest classifier, import accuracy score, I train random forest classifier with a fixed seed for reproductivity. Random forest is an assemble method that averages many decision trees, which make it robust to on noise and ideal tabular dataset like our. Then after I validate accuracy, there you can see that the validated accuracy 0.96, and then after finally I use train model to predict test set labels. This prediction will return into the simple submission data frame and save into submission file. Submission.csv formatted exactly as required by the computation for upload. So I conclude this notebook builds a clean baseline pipeline, data loading, encoding, imputation, scaling, random forest training, evaluation, and submission. Next step to improve performance including hyperparameter tuning, trying gradient, post model like Xpost. This workflow achieves reliable performance and validation and is ready for final submission. Thank you for watching.
My name is Debasis Prusty. In this project, I work on building a machine learning model to classify the interaction profile. I will explain my approach, the key steps in my notebook, and the results. The first, I installed the necessary libraries such as Aptuna and LightGBM. Then I imported the Python libraries like Pandas, NumPy, scikit-learn for preprocessing, and LightGBM for model training. Then data loading. I loaded the training and the test data sets from the provided files in Google Colab. I also cleaned the column names by stripping unwanted spaces. Next, I handled the missing values. Uh, Numerical features were filled with their median and categorical features filled with their mode. Then encoding features. Since machine learning models cannot handle tests directly, I used label encoding for categorical features. I encoded both training and test data consistently. Then feature and target repetitions. I separated the target column and applied label encoding on it as well. This gave me final feature set X and target Y for training. Then light GPM parameters. To make To make this model, I use Light GBM, which is efficient for classification tasks. I set the object to multi-class classifications, used multi-log as the metrics, and tuned parameters like learning rate, number of leaves, marks depth, norm leaves, feature fraction, uh, etc. Then cross validation and multi-seed enabling make the model robust. I use stratified k-fold cross validation with multiple random sets. This way the model learns patterns more consistently and avoids overfitting. In each fold, I train the model and validated it using a list of prevent unnecessary training. The prediction from all folds and seeds were averaged to create the final test predictions. You can see it here. And the last thing, there is generate submission. Finally, I converted the prediction back to origin class labels and created a submission file named submission4.csv. The file contains the ID and the predicted interaction profile for each test sample. And here is the download the submission4.csv file. And in my pipeline included the data cleaning, feature encoding, model training with light GBM, cross validation with multiple seeds, and generating the final prediction. This approach balances accuracy and generalization. Thank you.